Lesson 4.1. Key questions for Lesson 4.1 are: what terms can we use to describe motion? And how do the basic descriptors relate to one another? To start, we're going to take a look at some parameters or some terms that we're going to be able to change and take a look at how the picture changes. We have a very simple sort of program here. We've got a man located at a certain position along a meter stick in relation to some fixed objects on the screen. Now we can see that as time ticks on, the man is moving. But how do we know that the man is moving? You might think that an odd question. You might say, well, you just look at him. But in reality, we have to look at not only the man, but also the objects that are in the background, or those objects which I mentioned are fixed. We would define motion then as a change in the position relative to fixed objects. Furthermore, we can say that he went from -5 on the meter stick to +5 in about 10 seconds, or about 10 meters total change in the position in 10 seconds for a speed of 1 meter per second. We can call speed then a change in the position over time. If we look down at the bottom of the simulator, we see that the velocity is set at approximately 1 meter per second. Velocity is very closely related to speed. The only difference being that velocity includes just a little bit more information. In addition to stating the amount of change in position over time, it also includes a direction. So the velocity could be positive or it could be negative. If I set the man in the other direction, we can see that he can travel at 1 meter per second in the other direction. Alright, so he went about 10 meters again. I didn't reset the clock, so we're at about 20 total seconds of motion. So it was previously at about 10, it's now at about 20, so that's another 10 seconds. So he went 10 meters in about 10 seconds, or 1 meter per second. His speed was 1 meter per second, but we would say his velocity was -1 meter per second because he went in the opposite direction. In that example, we had the man moving at a constant velocity. What happens if we change the velocity? We see that changing the position over time causes a man to move at a constant speed. If we change the velocity over time, we do what's called acceleration. So down below, as you can see, I've set the acceleration at 0.51 meters per second, and it says meters per second actually squared. So it's meters per second each second. We're going to change the velocity here. We're starting at a position of about 5 meters, and we're going to move him to a position of 5 meters on the other side of the 0 mark. Alright, so there you see it took him about 6.3 seconds to get over to the 5 meter mark, which is a lot less time. But of course his velocity was changing constantly as he accelerated. Let's look at it again And because velocity is a vector, we can include the vector arrow and watch how it changes. Alright, so a vector is shown there with some length. It started out as having 0 length and ended having some length. So in other words, it started out having 0 velocity and ended with having 3.26 meters per second, as shown at the bottom there. Just a rough calculation shows us that he changed roughly 3 meters per second in close to 6 seconds. 3 meters per second divided by 6 seconds is about a half a meter per second each second. And sure enough, that's what we see down below. The acceleration is set to 0.5 meters per second each second. So our question was, what sort of terms can we use to describe motion, is answered by position, speed, velocity, acceleration. Those terms can be used to describe motion. And we can see that there's some relationship between them. Relationships between variables can be shown very easily using graphs. I have here now the same basic demonstration. A man will be moving across the screen, very simple. And we're going to start out with a constant speed. And we're going to see what that looks like. Here on the graph we have an x-axis that shows time and a y-axis that shows distance. Let's take a look at what this one looks like for constant speed. Alright, so there you have the man going from position of -5 meters to 10 meters. And the graph is very straight. In other words, there's no change in this way that this graph is changing. We can see that as we go over a certain amount of time, that a certain distance has been covered by the man. And if we look here, the total distance, or rather the total time that he traveled, was about 15 seconds. You can see that up at the top as well. And the total distance that he traveled was 10 plus 5, I guess you'd say, a total distance of 15. So 15 meters in 15 seconds, that's 1 meter per second. The slope of this graph is equal to 1. And so the slope of this graph is telling us that that's its speed. Let's do another example here where I increase the speed, and let's see what happens to the slope. Our man has been returned to the starting position, and I've doubled the speed to 2 meters per second. Let's watch. Well, you can see that the man covered the same amount of distance in less time, and the slope of the graph has changed. If we were to take a look at the slope of the graph now, we would find that it has a value of 2. And if you take a look at the distance covered, which is approximately 15 meters, in about 7.5 seconds, that also, if you divide those two, comes out to 2 meters per second. That's it for this lesson. Answer the questions that come at the end.